So the flag registers of 8086, which is given here, the program status word. So it contains the carry flag, auxiliary carry, then a register select and overflow, user flag and parity flag. So the details of the flag register will be covered in the next video. Okay, let's move on to the details of this 128 byte locations. So the very interesting thing here is, see, 128 locations I need to address. So the general mathematics that we can use to to solve this actually. So 128 byte means I can have up to 128 locations can be addressed using totally 8 bits. So that's the basic maths. So 128 locations can be addressed using 8 bits. Is it 8 bits? No, it is 7 bits. Sorry, it is 7 bits. 128 locations can be addressed using 7 bits. Minimum 7 bits required. 8 bits I can use, but minimum required is 7 bits. So if I'm using 7 bits, then where does the number starts? 7 bits means starting location is 00, 4 zeros, then 0000. This is the first location. Next location is 0000001. Next location. So on. So 000000010. So on, right? This will continue. Continue till what? 111111. So this value is, what is this value? This value is 7f. And what is this value? This value is 00. So a 128 byte of a location can be addressed using 7 bit, and the address of that 128 byte is ranging from 00 to 07f. That is the meaning that I am writing it here. So that's why there are 128 byte location addressing from 00 to 7f. So how these 7f locations, 00 to 7f locations are grouped? These 7f location, 128 locations are grouped into 3 parts. So that is the bank register. So this is called as a bank registers, register bank 0, 1, 2, 3, 1 set of location. Then it has a bit addressable area. Then it has a general purpose area. So there are fixed locations are given for each of this division, like bank registers are 00 to 1f, then 20 to 2f is bit addressable, and 30 to 7f is scratch pad memory. That's how it is divided. So after 7f, which number comes? After 7f, the number comes 80h. That 80h location is actually linked with the SFR. It's a continuation of the same. Okay, so let's move on to the details of this further. As I mentioned, how this RAM is divided. See, its starting address is 0 till 07, it is register bank 0. 08 to 0F is register bank 1. 10 to 17 is register bank 2. 18 to 1F is register bank 3. Then so this completes 4 banks, 8051 banks. So I will tell you more detail what is this register bank. Actually each location will be 8 bit, no? So such 8 registers are there in each bank. So here 8 register, here another 8, here another 8, 8. So totally 32 locations will be here. Next location start from 20H to 2F. 16 locations are there. 20 to 2F 16 locations. These are bit addressable RAM. After 2F the next number is 30, which will go till 7F, which is called as scratch pad memory. So this is how the 8051 RAM locations are split. So moving further, let's look into what is actually register bank structure. As I mentioned, the bank 0, register bank 0, it contains 8 registers. What are those names of the 8 registers? It is R0, R1, R2, R3, R4, R5, R6 and R7. That is the name of those 4 registers. So starting from the first location it is 00, then here comes 01, this is 02 location and here it is 07, correct? The next location starts with the next location bank 1, first bit is 08. So that's what is happening here. It is 00 to 07 is R0 to R7. Then again the next location is bank 1 where again it starts from R0 to R7. Now you may wonder why they have kept same name for all these registers that are not only. See, every bank first location is R0, the second location is R1 and so on. The last location is R7. So don't you think that it is confusing that each bank is having same registers? Actually it is not. So the thing is each of this bank, so R0 to R7 of register bank 0 and R0 to R7 of register bank 1 and register bank 2, even though notations are same, they are R0 only, but locations are different. So when you want to move some value to these registers R0, it could be of first bank, it could be of second bank or third bank or so on. How it will differentiate? The only way to differentiate is the register bank selection, where there is what you have seen it in the flag registers here, the bank selection register. So here what happens is the RS0 and RS1, there is a value for this bank. So depending on the value given here, now the value of this program status word will decide which bank should be selected. So generally this RS, the bank selection register. So what happens here is when this bit is 00, this RS0 and RS1, the bank 1, bank 0 will be selected. When it is 01, that means it is 01, then bank 1 is selected. Then it is 10, bank 2 is selected. And finally for 11, bank 3 is selected. So this is a way in which it is organized. So depending on the value of this PSW register, you are selecting a bank so that I can access the value of R0 registers. So if I am moving something to R0, it depends on which bank we selected. So if this value is 01, if I am assuming that the register bank values are 01, then definitely when this selection is made, then the value is loaded with R0 of that is 08 location. When the bank selection is made with the 2, then R0 is specifically made at 10H location. When the bank selection is made at 3, then R0 is at 18H location. By default, the value of this bank register is 00, hence whatever we do with this R0 to R7 will reflect in the first locations, that is 00 to 07. That is the default state. So this is how the bank registers are organized. And the overall structure, if you see along with the register values, this will go from 00 to 7, that is bank 0, 08 to 0F, that is bank 1, then 10 to 17, bank 2, and so on till 1F. Finally comes 20 to 2F, this is internal bit addressable RAM. I'll move on to this again further. And finally 30 to 3F, which is general purpose RAM. And finally it continues in the SFR. See here, this is 3F, this is not 3F, this is supposed to be 7F actually, 7F location, and 30 to 7F. Once it ends at 7F, the next value starts at 80H. 80, so on it completes. So this is how it is organized. Now let's move on to further detail about the bit addressable. See, bit addressable means 8086 has a special way of instruction handling. That is, I can handle an instruction where I can manipulate the data in a bit. Generally, we store a byte data, but if you want to store a bit data, then this space in the memory will allow you. What exactly they do here is, for example, if the bank 0, that is R0, I want to alter the first bit. I don't have any instruction for that. I have to do it in this bit addressable space. So if you want to change the first bit of this 20H, then you have to use the bit addressable instruction where you give the address as 00. So this 00 address is fixed for this bit addressable range. See, byte address is different, bit address is different. Byte address is refers to the entire RAM starting from the location 00, which is R0 of bank 0. Whereas bit address is the first location of this bit addressable memory, that is 20H. This 20H is divided, which has the 8 bit here. Each of these bits are addressed like 0, 1, 2, so on till 7. It continues. It continues till 16th bit, 16-bit byte data. The 16th byte, that is 2F location, will end at 7F. The beauty is here, the byte address also ends at 7F. The bit address also ends at 7F. That's why it is only 16 locations they are making it as bit addressable, not more than that. Because the reason is, now 8051 SFR has the 2080H location, that also most of the bits are bit addressable. Most of the registers are bit addressable. So they are mapping this location, continuity of this location, memory location to SFR also. That's why this is starting from 0 to 7F. So to be more clear what this bit addressable, we need to see few instructions. For example, see, there is instruction set bit, clear bit, complement bit, jump if bits, and so further detail I think we'll see, but these are some of the instructions that are used to manipulate these locations. So, or to be more clear, I can give an example how exactly this instruction works. So following are some of the instructions that you can see it is altering the values in this locations. See the first instruction here as set bit 42. Now set bit 42. Set is setting the value. B indicates for the bit. So it's a bit addressable instruction. Set bit what? Set bit 42H. So where is 42H? 42H refers to the internal RAM bit addressable memory. It is not byte addressable, it is bit addressable. So you need to look into the value between 20 to 2F only. Between 20 to 2F, you see what is the value. So where it comes. So here it is 0 to 7. Then where is the 42? Okay, 42 is here. So it will set this bit to 1. You can get the corresponding byte value with this 28 location. Similarly, clear 67. This is the 67th. So what does it mean? The D2 The second bit of the RAM location 28H. So this is the second, 0th location, first location, second location. And this is 2C, sorry, 67. 67 is what? 2C address last bit. So MSB bit of the 2C location will be cleared. Clear 0FH. 0F comes here. That is MSB bit of the 21H location, or the 7th bit of the RAM location 21H is cleared. And you see here set bit 28H. Again 28 you need to identify. This is the LSB of the 25th location is cleared. Set bit clear 12 here. Clear 12 is where is clear 12? See clear 12, see there is purposely they are not given H. Actually if you don't write hexadecimal, it will take the hexadecimal equivalent. If you write a decimal equivalent, 12 is nothing but 0C. That's why it is pointing 0C. That's why the value D fourth bit of the 21 location is cleared. Set bit is 05, fifth bit of 20H location is set to 1. So this is how the bit addressable instructions are used. So very powerful instruction, bit addressable, and the major use of this will come in SFR. I can manipulate the SFR location because after 7F the value continues in the SFR bit addressable registers. So that is about the bit addressable memory. For the scratch pad memory, there is nothing much to say because this scratch pad memory is 30 to 7F is a general purpose memory. Now one caution that you need to take. So the a general question may come, should I consider these locations as specifically for bit addressable, or specifically for the bank, or specifically for the general purpose memory? So nothing as such. You can, as long as you're not using the features of these bank registers bit addressable, then you can consider all these locations starting from 00 to 07F as a general purpose RAM. There is no condition as such. You can use this even 20H to 2F location as your general purpose area, no problem, unless you don't manipulate any bit using bit addressable instruction. So that is the only case should be taken. So to summarize this, so 8086 RAM is subdivided into three groups. One is bank registers, another is bit addressable, another is general purpose RAM. Please keep a note of all these. Register address, easy to remember, 0 to 7, 8 bits, 8 data, 8 to 0F, then 10 to 10, then 80 to 1F, that is bank register, then 20 to 2F is bit addressable, 30 to 3F is general purpose RAM or a scratch pad memory. So this is the overall structure of 8051 internal RAM.